Okay, gentlemen, we're going to try something a little new today. I'm going to use this video to help teach you about sketching polynomials. In this video, first, we've already learned about different families of functions and things that are very familiar. But what we're going to learn about today are different polynomials and how to sketch them. So these are the basic steps to sketch. First, determine the degree of the polynomial. So if this is something that's all multiplied out, it's going to be the highest degree of x. If it's not multiplied out, count the number of x's. Because what we're talking about are things that look like this. X to the fifth plus x to the fourth minus 3x squared plus 7. And that's going to equal y. So the highest degree of this polynomial would be 5. The reason that's important is because we want to determine if that is even or odd. Even polynomials end up with both ends of their graph heading in the same direction. So even generally kind of looks something like this. If this side is up, will be all these squiggles, and then this side would be up. Or if this side was down, there would be some squiggles, and then it would also be down. Odd functions end up looking like this, where one end is pointed down and one end is pointed up. And then they could go the other direction too. One end is pointed up, squiggles, one end is pointed down. This should sort of make sense to you because if you think about x squared, which would be an even function, that's a parabola where both ends point up. And if you think about x cubed, which is an odd function, that is the one that kind of looks like an S, where the ends go in opposite directions. Okay, after you determine the degree of the polynomial, the second thing we're going to do is determine the y-intercept. I'll talk more about that when we get to it. All right, number 3. We will determine zeros, which are also known as roots. Step 4, determine the sine graph. And then step 5 would be to sketch. Okay, so we will practice with these and I'll give you a bunch of examples. Once you're done watching this video, then you can practice with the other examples that I've left for you on Final Site. So first of all, let's call this A. Polynomials are continuous. So that means that their domain is all real numbers and their range is also all real numbers. So they are continuous curves. All right? So here's our first example. Y equals x times x plus 1, x minus 2, x plus 3. All right? So the first question was determine the degree. All right, if we multiplied that out, we would have x times x times x times x, which would be x to the fourth. So this is an even function. So that means that when we finish, we should have a graph where either both ends point down or both ends point up. Okay? So that gives us an idea of what it's going to look like. Secondly, let's determine the y-intercept. In order to find the y-intercept, that is when x is equal to 0. So plug in 0 for each x, then solve. In this one, it's going to be relatively easy because there's an x out front, which means that no matter what I multiply by, everything's going to equal 0. But this ends up looking like 0 times 0 plus 1 times 0 minus 2 times 0 plus 3, which equals 0. So therefore, the y-intercept equals 0. So what that tells us is that on our graph, it's going to go through 0, or touch 0, or something like that. It's going to go through the origin. Okay? All right, next we're going to find the roots. The roots are basically found by using the zero product property for each of those terms, or each of those factors in what we're talking about. So in this case, we would say x could be equal to 0, x could be equal to -1, x could be equal to +2, and x could be equal to -3. So I got all these by setting factors equal to 0. And remember, these are the factors: x, x plus 1, x minus 2, and x plus 3. Okay? So we know that it's even. We know that it's going to go through the y-intercept. And we know that these are going to be the roots. Now, what roots actually means is where the graph crosses or touches the x-axis. Okay? Alright, so in order to figure out what our graph is doing around those places where it touches the x-axis, what we're going to do is create a sine graph. So a sine graph is basically a number line, and on our number line we put the roots. And it's best to put them in numeric order just so it makes sense. So we've got -1, 0, oh shoot, I forgot -3. Okay, so we've got -3, -1, 0, and 2. And you can put them in, or I mean, you can put them like spaced out like they would be on a number line, because obviously there's a 2 in between -3 and -1, and there's 1 in between 0 and 2, but it doesn't really matter, because what we're mostly interested in is the space in between those. So for each of those curves, for each of those points, I'm going to put a little dashed line, because I want to know, what is my graph doing in between each of those points where it's actually touching the x-axis? Okay? And the way I do that is I choose a value that is in that area that I'm interested in. So for example, if I am looking at this area over here, that was not a highlighter, but whatever. There we go. If I'm looking at this area over here, what I want to choose is a number that would be less than -3. So we can choose like -4. And what we do is we plug -4 in for x. So plug in -4. And what I'm going to test is all of the possible values. So remember, our original function was x times x plus 1 times x minus 2 times x plus 3. Okay, if I put in -4 for x, that's a negative. If I put in -4 for x plus 1, well, that would give me -3, so that's still negative. If I put in -4 for x minus 2, that would give me -6, so that's still negative. If I put in -4 for x plus 3, that would give me -1, so that's still negative. But if I have 4 negative numbers and I multiply them all together, what sign will I get? Well, negative times negative is positive, times negative is negative, times negative is positive, right? So this ends up being positive. So on my little sign graph, I'm going to put a positive in a circle above the number line because that's where the positive numbers are, right? Because what we're figuring out is our graph is our curve going to be above the x-axis or below the x-axis? So from negative infinity to negative 3, our curve is above the x-axis. All right, so now let's look at this area. So we need a number between negative 3 and negative 1. Well, the obvious choice is probably negative 2. So we'll take negative 2. If I plug in negative 2 for x, I get a negative. Plug in negative 2 for x plus 1, I still get negative. Plug in negative 2 for x minus 2, I still get negative. Plug in negative 2 for x plus 3, I get positive. Haha. So if I multiply negative times negative, that gives me positive. And then that positive times negative would be negative. And negative times positive equals negative. Okay? So in this area, we're going to have our graph be below the x-axis in negative territory. Cool? Alright, so now we keep going. So now we need to pick a value between negative 1 and 0. So now we're in this area. Logical choice, probably negative 1/2, but you can choose whatever you want. It doesn't really matter, because mostly we just need to figure out the signs. So if I choose negative 1/2, that first term would be negative. The second term would end up being positive. Third term would be negative. Fourth term would be positive. Okay. Double checking, making sure that makes sense. I think I did something wrong. Negative for the first one. Nope, sorry. Yeah, positive for the second one. Negative for that one. Positive for that one. Okay, so we're good. No, we're not good. Something's wrong. Oh, I just wrote it wrong. Okay, so that term is negative. So it's negative, positive, negative, positive. Okay, so if I have two negatives, that makes a positive. Everything else is positive, so this is positive. So we are positive in this area. Okay, next we look here. In between 0 and 2, logical choice would be to choose 1. So if I choose positive 1, the first term is positive. Second term is positive. Third term, negative. Fourth term, positive. So this whole thing ends up being negative. And finally, we need information from numbers that are greater than 2. So this area here. And if we choose, say, 3, for the first term, it's positive. Second term, positive. Third term, positive. Fourth term, positive. So everything is positive. So we are positive. Okay? So you have to do that in order to figure out what your graph looks like. Now, if you've done your sign graph correctly, you should be getting an idea of what this curve is going to look like. Okay? And now we can actually just sketch it. So we'll draw our set of axes. Now we do want to put our numbers on in a scale. So if this is -1, this would be -2, -3, 1, and 2. We know that our graph is going to go through -3. It's going to go through -1, It's going to go through 0, and it's going to go through 2. And we know that our graph on the left side of that -3 point starts in a positive area. So we're going to start up here in the second quadrant, and we're just going to curve down through that point. Doesn't really matter how far you go. Turn around, we're going to go up. Doesn't matter how far you go, we got to go back down. Then we go up. And then we put arrows on the end of both of them, and that is our sketch for the polynomial x times x plus 1 times x minus 2 times x plus 3. Okay? Good.